The Energy Efficiency Design Index, EEDI, is conceived as an IMO mandatory instrument to be calculated and made as available information for new ships from 2013. EEDI represents the amount of CO2 in grams emitted when transporting 1 deadweight tonnage of cargo 1 nautical mile.
With regard to the G engines, there the essence is that we utilize a lower RPM. We have actually always been able to utilize lower RPMs by using our layout diagram with very flexible layout principles. What we do now with the G engines is that we push the whole diagram a little to the left. Thereby we get lower RPMs, thereby we can get the better efficiency of the propeller. Going from the S engine to a G engine, that means extending the stroke to bore ratio, thereby we get an engine with a longer stroke with a lower RPM. This gives also the better efficiency of the propeller.
The G-type engine has a design that follows the principles of MAN Diesel and Turbo's large-bore S-type Mark 9 engine, but whose ultra-long stroke enables the reduction of engine speed, thereby paving the way for ship designs of unprecedented high efficiency. Using the latest aft-hull designs that allow the use of larger and more efficient propellers, the new MAN B&W G-type engines will enable tankers and bulk carriers to operate at even lower speeds and fully exploit the savings potential this new technology offers. The development of the Capel propeller portfolio is the result of a concentrated body of work lasting over 2 decades. The Capel propeller minimizes the flow of water over each propeller tip, increasing the total efficiency of the propellers compared to conventional units. In combination with the G-type engine, Capel propellers can reduce CO2 emissions and fuel consumption by up to 10%. The most efficient way to increase the total efficiency of a ship with a 2-stroke engine is to utilize the engine's waste heat. This waste heat is primarily collected from the engine's exhaust gas. The MAN Diesel and Turbo developed Waste Heat Recovery, or WHR system, utilizes the exhaust gas temperature to heat up steam, which in turn drives an ultra-efficient steam turbine. When waste heat recovery is combined with NOx reduction methods, such as an EGR system, total efficiency can be significantly raised. The MAN Diesel and Turbo developed exhaust gas recirculation, or EGR system, is based on the principle of reintroducing a part of the exhaust gas back into the cylinder, thereby reducing NOx formation by lowering the peak temperature in the cylinder. In this way, up to 40% of the exhaust gas can be circulated through the EGR string of the system. The exhaust gas in the EGR string is first cooled down from 200 to 500 degrees Celsius to around 80 degrees Celsius by means of a pre-scrubber that absorbs and neutralizes sulfur dioxides and traps particles. From the scrubber unit, the exhaust gas is led through a water mist catcher that traps water droplets and prevents water carryover before the exhaust gas can be reintroduced into the scavenge air receiver. Tests of EGR units have displayed considerable reductions in NOx, with just a low penalty in terms of overall system efficiency. MAN Diesel and Turbo consistently invests in its research and development program to reduce the environmental footprint of its existing engines, introduces new, greener engines, and develops ever cleaner technologies that seamlessly integrate with its product portfolio.